Hello, my name is Scott Kroom. I'm a volunteer firefighter and an industrial firefighter. This is my first video, so please feel free to leave comments below. Let me know what you think and ways I can improve this video. So the reason for this video is because I do a lot of training around Canada and the United States, and a lot of departments or people use inline eductors. They're proficient with their inline eductors, however, they don't seem to know how to get the most out of their tools. So I'd like to do a short video on how to make your inline eductor perform to the best of its abilities without having to overwork anything else on the fire ground. For this video, I'm going to be using mainly TFT equipment. However, this technique, these tricks will work for all manufacturers. The reason I like TFT so much is because TFT makes a very nice product, both obviously for training and for the fire ground. But for training, their numbers on all their nozzles are nice. They're oversized, easy to do, easy to grip, so you can see when we make changes in the video, it'll be clear and obvious. Also using an inline eductor from TFT. This one here is a 60, but I will be using a 95 for the video. For those of us who are still using inline eductors as our primary source to produce finished foam, are generally taught you need to make 200 psi or 1400 kPa for this to pick up foam and work. Where this is true, the issue comes is not necessarily from pressure but from flow, where you can actually make this inline eductor produce foam at much lower volume or much lower pressures as long as you maintain volumes. I'm not trying to tell you that you need to change your policies or you need to change your guidelines or necessarily the ways you do things. What I'm trying to tell you is that these can perform at lower pressures, so you're not making people at the end of the line work very hard to produce foam. This information can all be found in the manufacturer's guides. It will give you distances and pressures for rated foams. So everything is based on the layout. So if you're running 900 feet of fire hose and you're using 1.5 inch or 38 mil, you're probably not going to be able to produce foam regardless of pressure because your volumes will not be there. You can play with this at your station and you can figure out what volumes work. Most departments have a preset length that you can run past your inline eductor. Please reference the user manual to get their recommendations. So I have a quick write-up here. I just want to read real quick. So this is directly from the manufacturer of an inline eductor. The percentages shown on the metering device only applies to the correct eductor inlet pressure, 200 psi or 1400 kPa. If the eductor is operated at less than 200 or 1400 kPa inlet pressure, then thus lower flow through the unit will result in a solution will have higher percentage of foam concentrate. With inline pressure higher than 200 psi or 1400 kPa, the foam solution will have a lower percentage of concentrate. So what this means is, if you have the inline eductor set at 6% and you flow 200 psi or 1400 kPa, you will produce exactly 6% foam concentrate at the end. So again, what your unit is rated for. But if you pump the truck at 250 psi or 1700 kPa, you'll actually get 5.5% foam at the end. If you reduce the pressure to say 150 psi or 1000 kPa, the solution will be 6.9%. You're actually increasing the production of foam. And again, 100 psi or 700 kPa, you're going to be producing 8.4% foam concentrate. So despite what you might feel as when you increase pressure, you increase the amount of foam, it's actually the backwards. When you decrease pressure, you increase foam production. The nozzle I'm using is a 30 to 200 GPM nozzle, which for those of you in metric is 110 to about 750 liters a minute. Just make sure that you know most nozzles will come in either liters or GPM, but the inline eductors basically always will come imperial. So just make sure you know if it's an imperial nozzle, you know the matchup for the inline eductor. Easy. For liters, maybe a little more confusing, so just make sure you know that beforehand. For this training video, what we have is a setup of the inline eductor directly off the pump. It is a 1.5 inch or 38 mil. Connected to it is 150 feet of hose. It's going to be 90 meters or 1.5 hydraulic lengths. At the end of our setup, we will be running a thunder fog like we talked about before, the 30 to 200 gallons per minute. Again, 110 to 750 in liters. We're going to show you how to make this become an on-off switch. Firefighter Matt has his nozzle set for 30 GPM. When he opens up his nozzle to the completely open position with the inline eductor in place and in the foam pail. You can see that he is clearly flowing water. By simply adjusting the gallonage to the rate in which matches the inline eductor, 95 on this particular unit, he essentially has created an on-off switch for his foam production. This allows him to switch easily between foam solution and cooling water without having complicated radio communications asking for foam or no foam. Just as simple as turning the inline eductor on with your nozzle. When he turns back below 95 GPM, foam will stop. Again, very important that you notice the delay from foam on and foam off to foam on. A lot of times firefighters think that they haven't put the pail or haven't hooked up their foam because they're not flowing, and this is only because it hasn't made it all the way through the line. Same as when they ask to stop flowing foam, they may not believe the operator has pulled the eductor out of the pail because they flow foam for up to a minute after we have turned off the foam supply. If firefighter Matt turns the nozzle back to 95 GPM and then gates the nozzle back halfway, as firefighters, we often gate the nozzle to get that comfortable nozzle reaction that we like. But what we've essentially done is changed the flow. So he switched to 95, so he picked up foam, as he should have. But as the foam clears the line, he has now gone back to mainly water. This is because he has now changed the flow, not the pressure.
With the basic information in this video, try your station adding more hose past the eductor and see how far you can get. As you add lines, increase the flow at the nozzle until you hit 200 GPM or 750 liters per minute, the maximum of most nozzles. Thank you, and I hope I've challenged the attitude, this is the way we've always done it. And always remember, the greatest enemy of knowledge isn't ignorance, it's the illusion of knowledge.